Hi, ladies and gentlemen. I wanted to go over a couple example problems from this homework assignment with you. The first one being number 2, because we've gone over number 1 in your notes already. So please check back to the example problems for this answer right here. Number 2, a girl is hanging from the monkey bars at a playground. Diagram the forces acting on this girl. Now, just like we did in our example problems, I'm going to go up to shapes. I'm going to grab a box here because every object is represented by a box in our force diagrams. So I've drawn that box right off to the side. Then I'm going to go up here and I'm going to grab an arrow. Now we know this girl is on Earth. So our free B force, as I told you would be on every diagram, is going to be our downward force of gravity. Again, if you hold the shift button, it helps you draw a perfectly straight arrow coming out of our box. And then we're going to go ahead and label that FG. So capital F, lowercase g. Let me make my text box a little bigger so that it will actually sit on the same line. There we go. Now, this girl is hanging from the monkey bars. If you're hanging from the monkey bars, you're going to have to pull upward on those monkey bars. So she's applying a force on those monkey bars. Now, it doesn't say anything about her accelerating in any direction, so it's safe to assume that she's staying right where she's at. Now, as a result, we're going to make our applied force and our force of gravity about the same. Hold on one second. I don't know. There we go. So try to latch onto that little dot there. All right. So those two arrows are about the same length now. All right. There we go. And I'm going to go ahead and label this FA for our applied force. Now, these two arrows are about the same length, so we can assume that the forces are balanced, which, because this doesn't tell us anything about an acceleration, we can assume is the case. This would be a completed force diagram for number 2. Now, let's take a look at number 7. A college student has a backpack on his shoulder. The pack is suspended motionless by one strap on his shoulder. Diagram the vertical forces acting on this backpack. So they go ahead and tell us that we don't have any side-to-side forces here. Again, I'm going to start off by going to, or we can either click shape here or go to insert and select shape. And I'm going to select a box. All right. And then we select our arrows. So again, we know our free B force is our downward force of gravity. All right, and then we include our text box right here, FG. And then we're going to have our upward force. But the question here is, what is our upward force going to be labeled? We know it's going to be balanced because the backpack is at rest on the student's shoulder. So let's go ahead and first draw that equal force upwards. But because it's a strap, we're going to go ahead and label this a tension force. So FT, like a rope or a cord. All right. And that, again, would be a completed force diagram. Now, guys, if you're going to complete these off to the side like this, I'd ask that you try to stagger them or do this right here. You can use arrows to show me which one is which question, or you can number them with a text box and put that text box right off to the side and say, that one's number 2. And then we can do the same down here and say that one is number 7. Now, if you don't like doing this on the computer and you'd rather do this on paper, please, you're more than welcome to do this on paper and upload that to the digital notebook. But make sure you're uploading it to the digital notebook so that we know where to find it. All right, guys, that concludes our example problems. If you're having any trouble with this or need any further help, please contact your physical science teacher, sign up for their office hours, and we'll be more than happy to help you out. Have a great day.